Hi, this is Dr. John Bergduff. In this video, we are going to look at rational inequalities, and we're particularly going to look at how to solve a rational inequality with the aid of a graphing utility, like a graphing calculator or a computer program that graphs. Now, there are as many different ways to show how to solve a rational inequality, I think, as there are math teachers alive on the planet at any given time. This particular method does rely on technology. If you are currently taking an algebra class, college algebra or high school algebra 2, and your instructor or teacher wants you to not use technology but to use strictly analytic techniques, then this video will not actually be what you need. However, if you are in a class where you're really looking at an application of a rational inequality and you need to solve one fairly quickly, this technique can be very nice for getting a solution very fast. And if you're in an algebra class that requires an analytic approach, you can still use this as a check. So first of all, I guess we should talk about what a rational inequality looks like. This is a rational inequality. It is simply a rational expression, which is a fraction where the numerator and denominator could contain polynomials. And what makes it an inequality is that it is either less than, greater than, less than or equal to, or greater than or equal to something else. So for the technique that I want to show you, the first thing that's important is that you have to get a 0 on one side first if you don't already have that. We're not going to do one where you don't have a 0 on one side. We're going to kind of keep it simple. Once you have a 0 on one side, define the non-zero side to be f of x. And you're going to sketch the graph of that function with the aid of a graphing utility. How is that going to help you? Well, if you focus on the fact that this is the function and you want it to be greater than 0, the inequality is really asking for what values of x is the graph. Greater than 0 means above the x-axis. So we are simply going to look at the graph and ask ourselves for what values of x is the graph above the x-axis. If that inequality right there had been instead a less than, that would mean we'd want to be below the axis. If there was an inequality included, either than in a greater than or a less than, that would also mean we would want to be on the axis. So at this point you might be thinking, oh, very simple, I'm going to get my graphing calculator or my computer program out and draw the graph and all will be well. When you look at the graph, there are going to be some details that are not obvious. So there are a couple analytic things, algebraic things that you do want to do to get ready before you look at the graph. And those are going to be built on two essential facts about the graph of a rational function. If you have a rational function is simply a function that consists of a polynomial in the numerator, I'm going to call that n of x, and a polynomial in the denominator, d of x. This again is our inequality and our function. And the first fact that you need to know is that the graph will have x-intercepts at whatever values of x the numerator is equal to 0. So I am going to take the numerator and set it equal to 0, which will be a very simple equation to solve. I'll subtract 5 from both sides. That gives me 2x is equal to negative 5. And I'll divide both sides by 2. And that's going to give me x is equal to negative 5 halves. That means that negative 5 halves 0 is an x-intercept, and in fact the only x-intercept of this particular function. When we look at the graph, it's going to be a little bit more useful to realize that negative 5/2 is negative 2.5. So hang on to that thought. That's one essential fact you need to know. And then there is one other, and that is that, and this is supposed to be 2 here, I'll fix that. The graph of the function will have vertical asymptotes for the values of x for which the denominator is equal to 0. So to get the x-intercept, set the numerator equal to 0. To get the vertical asymptotes, set the denominator equal to 0. In this case, that'd be x squared minus 2x minus 3. That's a quadratic expression. We can solve that by factoring. I have other videos on my channel about factoring if you need a little help with that. This one will factor as x minus 3 times x plus 1. Minus 3 and 1 are two numbers whose product is negative 3 and whose sum is negative 2. Take the factors, set them equal to 0, and we will see that there's going to be a vertical asymptote at x equal 3 and another vertical asymptote at x equal to negative 1. That work is going to be helpful because now I am going to look at the graph of this function, and just looking at the graph, it may not be obvious if you didn't check these facts first. So I have drawn this graph using the computer program Desmos, which I really love. It's simply at desmos.com. It's a free app. It graphs functions very simply by just typing it in pretty much the way it looks. And this is the graph of the function. Now what we have found out, and you'll see now why this is important, is that we have a particular x-intercept and we have a couple of vertical asymptotes. Those may not be totally obvious looking at the graph, but when you look at the graph, I think you'll agree that it pretty much makes sense. Here's the x-intercept. Notice that the little marks there are counting by half units, so negative 2.5 is exactly there. The vertical asymptotes might be hard to see if you hadn't done the work in advance. There's one at x equal to negative 1. I'm going to draw a dotted line in there to represent that. And x equal 3. Here's a little dotted line, I guess dashed line, to represent that. Now, back to the inequality. The essence of the inequality is that you called the non-zero side f of x, so you're really asking where is f of x greater than 0, and that's really asking for what values of x is the graph above the x-axis. And with the little detail that you add in, it's pretty clear. This graph is above the x-axis for this little region right here, from the x-intercept to the vertical asymptote. I would represent that in interval notation as negative 2.5, or negative 5/2, to negative 1. The graph is below the axis here, but goes back above the axis over here. That would be over the interval from the other vertical asymptote off to infinity. That would be 3 to infinity. And as you can see, with very little work, looking at the graph, enough work to know where the x-intercepts and vertical asymptotes are, you can get the graph, you can get the solution of the inequality pretty simply. So I hope that'll be really helpful. Again, if you're in a class where your instructor wants you to show more analytic algebraic work, you can at least use this as a check. Hope this helps.